Hi everyone, this is Rajan Kumar Pandey and my project topic is analysis of composite material using natural fiber, and my teammate is Munish Kumar, and we are from Weltech High Tech, Dr. Rangarajan, Dr. Sakuntala Engineering College affiliated to Anna University. First we will see overview of composites. The advantage of composite materials over conventional materials stem largely from their higher specific strength, stiffness and fatigue characteristics, which enables structural design to be more versatile. By definition, composite materials consist of two or more constituents with physically separable materials. However, only when the composite phase materials have notably different physical properties, it is recognized as being composite material. Composite materials are that comprise strong load carrying material known as reinforcement embedded in weaker material known as matrix. Reinforcement provides strength and rigidity, helping to support structural load. Constituents of composites retain their individual physical and chemical properties, yet together they produce a combination of qualities which individual constituents would be incapable of producing alone. The reinforcement may be platelets, particles of fibers, and are usually added to improve mechanical properties such as stiffness, strength, and toughness of matrix material. Long fibers that are oriented in the direction of loading offer the most efficient load transfer. Matrix is a role of matrix in fiber reinforced composite is to transfer stresses between fibers, to provide barrier against adverse environment, to provide the surface of the fibers from mechanical abrasions. And the types of matrix are metal matrix composites, ceramic matrix composites, polymer matrix composites. Fibers used to reinforce along with the matrix. Fibers reinforced polymer composites have played a dominant role for a long time in a variety of applications for their high specific strength and modulus. And we will see now filler and additives. Fillers are added to polymer matrix for one or more of the following reasons: reduce cost, since most fillers are much less expensive than matrix design; increase modulus and reduces modulus shrinkage; control viscosity and produces smoothness. We will see now coir fiber. Coconut fiber is extracted from the outer shell of a coconut. It is also called coir fiber. The common name, scientific name, and plant family of coconut fiber is coir, Cocos nucifera, and Ericaceae. It is also called palm. Figure 1 and so 2 is going to show about a coconut and coconut fibers. This is a coconut fiber arranged in a bundle. Next, this is a coconut. This is called outer shell of a coconut, and this is white form. This is called brown fiber. It is very strong in its properties. This is longitudinal and cross sectional of fiber cell. Inside outer part is called cell wall. Inner part is called lumen. This resembles closely to a hollow shaft, and that's why it's more suitable than a solid shaft. Resins are the materials used in a fiber reinforced composite, are sometimes referred to as polymers. All polymers exhibit an important common property in that they are composed of long chain molecules consisting of many simple repeating units. Man-made polymers are generally called synthetic fibers. In our project, we have used the hand layup technique. Hand layup, the simplest fabrication process, is another open mold process. Hand layup uses no mechanical spraying or chopping equipment for depositing the resin or glass reinforcements. This process involves the same using spray layup. Following gel coat application, alternate layers of catalyzed polyester resin and reinforcement material are applied. The ratio of resin to glass is usually 60 to 40 by weight, but varies by product. This is a hand layup technique. This is the material here is called resin. This is a brush and applied with resin. While rolling, we will be applying uniform matrix and resin. After completing layer of one, we will apply another layer. Method and procedure used by us: we use open molding as it was comfortable for us. This is also known as open molding. And the accelerator and catalyst has the property of hardening. The normal ratio around 22:1 for a ratio of accelerator and resin. 5 ml of catalyst is used. The skeleton comes from elsewhere, and that is known as fiber. And the fifth member, the brushes, obviously, is to apply the mixed solution for resin. The brushes, I mean this is the brush, roller brush. Here we will be using cardboard. Create an exact shape which you make. Cut the mat into shapes suitable to cover the surface area of a cardboard shape. Mix resin, catalyst and accelerator. Apply a coat of above solution to the cardboard surface. Using pieces of cut mat from a layer of mat over a freshly coated surface. Apply multiple layers of a solution over the mat layer. An exothermic reaction kicks off soon, and we'll apply load, keeping it 50 kg for 2 days. And this is a final material photograph of our material we have produced, and we have found that our Rockwell hardness is around more than 250, and it is suitable for making a like boat dinghies, which will be very cheap. And thank you.